All right, we're going to go on to an interesting topic called the unit circle. Now, the unit circle is a really clever idea, but let's talk about it some more. So recall from a previous lesson, if pxy is any point on a terminal arm that is in standard position, then it can be shown that cosine theta is x over r, the radius vector. Sine is y divided by r, and tangent is y divided by x. So to gain greater insight into mathematics, you don't need to make it more complex. So sometimes you just have to look at things differently, and things become much easier. This is the way of the unit circle. So let's consider a very special case where r, our radius vector, is 1. Under this very specific condition, the trigonometric ratios are greatly simplified. So under this very specific condition, with r being 1 on the unit circle, the trigonometric ratios become cos theta is equal to x, sine theta is equal to y, and tangent theta is equal to y divided by x. So what is the unit circle? So often people use this in the wrong context. The unit circle simply is a circle with center at 0, 0, and that has a radius that is equal to 1 unit, the unit circle. So what are all the possible angles where the radius is equal to 1? Well, I guess, let me just start. There's my terminal arm. And maybe this is my angle theta. Now, I'm not going to draw my terminal arm. My terminal arm. I'm just going to draw the points that it could be, right? So what ends up happening, if my radius vector is 1, for instance, this triangle, I could have that point. So that the distance from the origin to the point is exactly 1. I could also have one up here, right? And I'm sure I could be more clever than this. Anyways, I'm just trying to show you that what creates a distance of 1 all the way around the circle, all the way around the origin, is just a magical shape called a circle. So you could draw all the possible angles. Now, I'm going to try something fancy. Oh, let's do this. I'm going to try to draw a circle. Oh, there we are. Radius 1. So there's my unit circle. There are all the points that have a radius, or that are 1 unit away from the x-axis. That's what the unit circle is. So the loci on all vertices of the terminal arm follows the unit circle. So if you take a terminal arm of an angle and just simply move it around the circle, and if you had a pencil at the end of that terminal arm, right here, say for instance, and you move this all around the unit circle in various positions, sorry, my palm was, it would just follow the unit circle. Anyways, the equation of the unit circle is x squared plus y squared is equal to 1. Now we don't take that, that's called a, this type of equation is called a conic. We no longer take conics in high school, but it definitely helps us out. So let's apply some theory to some situations. I am going to draw 0 degrees. Here is my angle of 0 degrees. And I know I have this point here. What are the coordinates to that point? The coordinates to that point are going to be 1, 0. So this is at 0 degrees, or you could say it's at 362. Anyways, that point on my terminal arm is 1, 0. Fabulous. Now, let's keep in mind that when our radius is equal to 1, sine theta is equal to y, cosine theta is equal to the x-coordinate, and tangent theta is y over x, or it's the slope. So, without reaching for a calculator, I can say that the sine of 0 degrees is equal to 0. Right? Sine is the y-coordinate. Cosine of 0 degrees is equal to, well, the cosine of 0 degrees is 1. The tangent of 0 degrees is going to be, what is that slope of my terminal arm? 0. Or it's your y divided by my x. 0 divided by 1. Fabulous. That was a good lesson. I liked it. Now, allow me to draw the angle 180 degrees. So there's my terminal arm, there's my initial arm array along the positive x-axis. Here's my terminal arm, and since we're on the unit circle, it has a radius of 1. So the distance from the origin to here is 1. So we know that this point is -1, 0. So what do I know? That the sine of 180 degrees is equal to. So I take a look, where is 180 degrees? 180 degrees happens to be along the negative x-axis, and on the unit circle, it would have coordinates -1, 0. So the sine is the y-coordinate. Now, if you want, you can take out your calculator and say the cosine of 180 degrees is going to be -1, because the x-coordinate is -1. The tangent, out of theta, we have a specific angle here. The tangent of 180 degrees. Now, what is the slope of my terminal arm? 0. Alternatively, you could say it's my y divided by my x, which ends up being 0. There's your sine, cosine, and tangent for 180 degrees. You know this already. It's amazing the stuff that we don't know, but we don't know we don't know. Or we don't know we know, pardon me. So there's my initial arm. I'm going to draw my terminal arm at 90 degrees. 90 degrees here. You'll often hear me refer to this at the top of the house. This point will have coordinates 0, 1. So 90 degrees, now, what can we say? We can say that the cosine of 90 degrees is equal to 0, because it's the x-coordinate at our terminal arm. The sine of 90 degrees is going to be 1. The tangent of 90 degrees is equal to, well, it's my y-coordinate, 1, divided by 0. So the tangent of 90 degrees is 1 divided by 0 is going to be 0. Just kidding, it's not, right? 1 divided by 0 is undefined. And if you took a look and asked yourself, what is the slope of that terminal arm? The slope of a vertical line is called undefined. Very, very similar to what we have done before. Now, let's move on. Here's my initial arm. My terminal arm at 270 is straight down, so my angle goes, all the way around here. There's a point that exists on that terminal arm. Now, we're 1 unit away. It has coordinates 0, -1. So if you want, you can test this out in your calculator. The sine of 270 degrees is the y-coordinate of this point, -1. The cosine of 270 degrees is the x-coordinate. The tangent of 270 degrees is y over x, Or you could ask yourself, what is the slope of this blue line? And it is also undefined. Pretty nifty. Anyways, without doing much work, now I have a way of thinking what is the sine cosine of tangent of 0 degrees, 90 degrees, 180, 270, and 360. Note there's a very special connection between 0 and 360, that they end in the same place. They are coterminal. They're not the same angle, but they are coterminal.